part, let's see, let's write this down, part 3 of kinematics. And today we're going to be dealing with a different type of equation and something I wasn't able to fit in before. If you guys did have questions on distance, I will clarify with another example. So let's say like 1 goes 100 meters east, but then he walks back with 40 meters west. And then in order to find the average speed, so speed equals distance over time, and the total distance would be 140. But then let's say he covered all of this distance with 10 seconds. So your time would be, or your distance would be 140 over 10 seconds, which is just 14 meters per second. And then again, this would apply to average velocity, which is just the change in displacement over time. But with displacement, remember, it does have directions. So this is what you would see as positive, and this you would see as negative. So 100 minus 40, you get a total of the 60 displacement or distance over time, which again is 10 seconds. And the average velocity would be 6 meters per second that so and so traveled. So that would be a distance versus displacement problem. So that would be that. And then moving on to a bigger problem, let's say a truck. Let's just draw truck instead of actually writing out the word truck. Don't make fun of my truck. So let's say a truck slows down from 40 meters per second to 12 meters per second. But during this time, he did travel 800 meters total. And you're asked to find what is the average velocity and your average, not velocity, and then this is average acceleration. And then how long did it take to decrease its speed? So let's take what we do know and what we don't know and what we're trying to find. So we know our x initial is 40 meters per second. Our x final is 12 meters per second. Our distance is 800 meters. We're trying to find acceleration and we're trying to find time. One of the first equations you do want to use, or excuse actually, let's backtrack a little, excuse those x's because these were speeds. So initial speed, final speed, velocity. So one of the equations out of the 5 that have all of these given would be the first one, not the first one, I don't know what order you keep it in, but it would be the one which find the velocity squared equals your initial velocity squared plus 2 acceleration times distance. Here you would plug in your final, which is 12 squared equals 40 squared plus 2 times a, because that is what we're trying to find, and times your distance, which was a total of 800 meters per second. So all you want to do now is isolate a. You want to isolate a. So 12 squared is 144. 40 squared 1600 plus a times 600 1600 meters per second. So here you want to solve for a, so it'll be minus 1600 from the 144. You want to do that on both sides, and you do get negative 1456 equals a times 1600 meters squared. Again, you do want to isolate a, so you would do the opposite of what is being done. So if it's multiplying, you would divide. So it'd be 1456 divided by 1600. You would get your acceleration equals negative 0.91 meters over second squared. Always want to make sure your notation is right. So for acceleration, I didn't mention it earlier in the video or in the past video, but it's going to be meters over second squared, or whatever your distance is, but always make sure your seconds are squared. So the average acceleration for the car that goes 40 to 12 would be 0.91, because it did decrease, so there's a decrease, and that's where you do see the negative. Okay, now let's do the second part, where it does ask for um, the seconds. How long did it take to decrease the time? And again, you want to take into consideration any equations you do know already. So like the previous video, we would use d times 1/2 times your initial plus your final and times time. And again, you would plug in your velocities and distance or anything you already have or know. So it'd be 800 meters, which is how far the truck traveled, times 1/2, and then your initial, which would be 40, your final, which should be 12, and then what you're looking for is your speed, or how long it took to decrease its speed from one point to another, which would be what we're looking for. Questions for your speed, or how do you know what to plug in? It's depending on what it's asking you from. So in this example, it's asking you how long did it take to decrease from 40 to 12. In other examples, it can ask you how long it took to decrease from point A to point B, C to D, E to F. You just have to know what you're looking for, and just make sure you put two and two together. If you guys want a video on that, I can also help you guys find out how to do that. So now we just want to isolate T. We want to get rid of the 1/2 first. So I would times 2 on both sides, so I get 1600. Let's see. Meters equals 40 plus 12 times time. 40 plus 12, 52 times time equals 1600. Again, this is pretty simple math. Kinematics, it may be confusing because it is physics, but it is just plugging in and recognizing the formulas and when to use them. So here you can see that we have from 40 to 12 would be 37.77. Oh, 30.77, my bad, seconds. And if you want to know where the units went, it'd be down here, whether it's 40 plus 12. And since you are dividing, there's our seconds. Units would cancel out, and you're only left with seconds. So it would take a total of 30.77 seconds, and for it to decrease, and the acceleration would be a total of negative 0.91 meters per second squared. So we can just fill that in. Hopefully that made sense to you guys. This is just a quick breakdown or easy way to solve problems. And this would be part of the second, or part 3, learning how to use the other kinematic equations.